Okay. Um, so till last week we did till question number two. We finished this. So we're gonna start with question number three. It basically builds upon question number two. So probability, assume that the life expectancy distribution among the countries follows a normal distribution. Using the data from section C in the previous question, average life expectancy rounded to zero decimal positions, calculate the average and standard deviation for the average of life expectancy for all the countries. Um, so we had this what was it? The life expectancy, we rounded it up, right? And we want to take the average and standard deviation of this. So we can do that by taking the mean or so using the average formula here. So for taking the mean of all of these values, we can use the average of this whole range of values, right? It should be 199. Yeah. Yeah. So, and then standard deviation also. So for the standard deviation, you can use the formula standard deviation dot p. Um, and that would give you the standard deviation. So once you have that, if we randomly select a country from the list, what is the probability of selecting a country with an average life expectancy for the last 10 years, which is greater than 75 years, right? So go to the question here. Where it is. Yeah. So we can use the formula for this. So remember, if you want to get like what is the probability of selecting a value which is larger than a certain value, um, we can use the formula normal distribution, and we need to give it four different inputs. So first input is the value that we want to choose. We want something larger than 75, so that would be the x first. Then you give it the mean. Um, you can give the mean, so the mean is rounded to two digits, but more appropriate would be to use the exact mean. So we can pull it from our from here that we calculated. And then similarly, the next input is your standard deviation. So we use that. And then we say we want the cumulative uh, um, function, right? So this will give you the probability of choosing something below, right? Because once you have that normal distribution curve, this will tell you everything behind that value, right? So everything below 75 years. So this is the probability of selecting a random country or random value, and that being lower than 75. But we want for higher than 75. So we just need to subtract that value from one. So this would give you the probability of that. Right. So that's question number three. Any questions? Is everything clear? Okay. Yeah. Wait, what a question. Oh, okay. Sorry. Sure. Okay, so question number four is hypothesis testing. So assume that the life expectancy distribution among the countries follows a normal distribution again, and that all samples have equal variances. Calculate the standard error for the average life expectancy calculated in 3A for the last 10 years. So we want to calculate the standard error, and the standard error is basically standard deviation divided by the square root of n, right? So in this case, our standard deviation would be we can pick it from here that we calculated, uh, and that divided by um, square root of the total count that we had. Um, So the total count of average life expectancy. So you can have this. We created the summary sheet. So average life expectancy, the total count is we have 19,1970 values, right? So we can just pick that, and that would give you the standard error. So this would be the standard error. Okay. So provide a 95% confidence interval for the average life expectancy for the last 10 years. So for that, we need to calculate the confidence value. The confidence value, which would then be used to calculate the confidence interval. So for that confidence value, you can use the formula confidence dot T, and that would take you that you would need to give it three um, different inputs. So first is alpha, which is your alpha value that depends on the confidence interval that you want to calculate. So you calculate 95%, so your alpha is 0.05 or 5%. And standard deviation, again, you can pick it from here that we calculated. Um, and then finally, you give it the size, which we saw it was 19,1970, right? So this is your confidence value, and then you can calculate the lower and upper bound to it. So your lower bound would be your average, the average minus the confidence value that you calculated. So average is here 72, and this minus your confidence value here. Um, right? So that's your lower bound, and then your upper bound would be just this average plus uh, the confidence value. Sorry. And so this is basically not exactly 72. This is 72.172, right? That's why you are seeing these differences. So these differences is because in the key we use manual value of 72, but this is the more like accurate answer because your average is not rounded, right? So this is the confidence interval, 95% confidence interval. So we want to see if average life expectancy for the last 10 years across all countries is lower than 72.5 years, which is, average life expectancy for the previous decade. So we have that statistic from the last decade, and we want to see if our average life expectancy for the last 10 years, which for which we have the data, is it lower than 72.5 or not? So write the null hypothesis. So null hypothesis, average life expectancy of all countries for the last 10 years. It's not statistically different from 72.5, which is, the average life expectancy is equal to 72.5. And the alternative is that average life expectancy of all countries in the last 10 years is statistically lower than 72.5. So what kind of test would we use for this? One tail or two tail? Anyone? I mean, is there in the key, but can someone explain why we would use one tail and not two tail? Take a guess. Anyone? So basically, we're using one tail because we are only concerned with. So we are saying that the mean is the average life expectancy is lower than 72.5, right? So our null hypothesis is that the average life expectancy is equal to 72.5, but the alternative is that it is lower than. So it can only be in one direction. So we are not concerned with higher than. We're concerned with lower than, right? So that is why it's going to be one tail test. If we had said that so our null hypothesis was that average life expectancy is not statistically different from 72.5, but our alternative hypothesis was that average life expectancy is not 72.5 and it could be higher or lower, then we would use the two-tail test.
I agree with the lower, the higher is okay, right? We don't care. If it's higher, the better. The non-hypothesis probably will be better if you. I mean, it will be more explicit if we frame it as like the average life expectancy of all countries from the last 10 years is not statistically smaller than
Oh,
that, right?
yeah.
So that will simplify the direction.
Yes. Yes.
Like the alternative is more confirmative. There is
Yes.
no, it's not. It is still a null hypothesis, but it with a clearer
Yeah.
signal of direction. Makes sense? Because you want to make that the
Yeah.
direction explicit instead of implicit.
Yeah. Yeah. You're right.
Yeah.
So yeah, we can use the null hypothesis also. Um, so yeah, so that will give you the direction. So we're using one tail test, and so the data for the previous decade's average life expectancy is contained in sheet 4C. Conduct the appropriate hypothesis test, one tail or at a level of significance. Report the t statistics, p value, and provide interpretation of your results. So if you go here, 4C, this is the previous decade, and then this is your life expectancy for this decade, right? Uh, And that data is basically 72.5 because you are assuming that it's 72.5. So all values, you're hypothesizing that they are 72.5. It's going to give you the same result. So this data is given, and you can copy paste your life expectancy for this decade from when we had this, we copy pasted here the values, so you can use those values, right? So once you have these, uh, you can then do the uh, test. And for that, I showed you the tool pack here, right? Um, so if you use this tool pack, I hope all of you have downloaded it and have it in your Excel. So we are going to use um, two sample assuming, uh, wait. Right. So we are going to be using two sample tests assuming equal variances because initially in our question, if you see here, we had said that all samples have equal variances, right? So we're just going to make that assumption. So in this case, we are going to use t-test two sample assuming equal variances. So your variable one range would be the average life expectancy for this decade. So you can select all those values. And so you have those, seven, I don't know how many values, 1970 values, right? And then your variable two would be uh, all these values for the previous decade. And hypothesize mean difference is 0. And let's get our result on this sheet. So let's say we wanted an F1 here, right? So once you get this, so you'll get this result. Is everyone getting this result? Yeah.
Back up to just a little unclear aspects.
Okay. I'll have to open another one, but you can ask me. Yeah. So what is confusing?
The hypothesized mean difference.
0, because our null hypothesis is that there's no difference in difference.
Okay, all right, thank you.
Yeah. Okay. So everyone's getting this, right? So if you see here are t statistics. So in this case, you're also concerned in the sign of the t statistics. So in this case, the t statistics is negative, which means our mean is lower than 72.5. That's why it's negative and on the left side of what a hypothesized mean is. But you also look at the p-value. So p-value is 0.07, right? Which is higher than 0.05, right? So in this case, you would accept the null hypothesis and you would say that our mean is not uh, lower than or statistically lower than 72.5. So we would accept the null hypothesis and we would say that our mean is statistically similar to 72.5. So it is not lower than 72.5. Uh, okay. And so part D, now we're doing the standard errors for average life. So everyone gets the 4C that we did, the t-test. You understand it? Any questions? Good. Yeah.
What if we're unable to add the toolpath having,
What do you mean? Like you haven't been able to add it?
just check all
Error? What kind of error?
the commands. And then that for ever.
Sometimes, if you use a university's email account, login,
Yeah.
constantly there are almost 360.
Mhm.
I don't.
I am using the first two, also maybe it's which is allowed.
Okay. So
Yeah, they should have. They will give you more, no less. Yeah.
we want to calculate the standard error of um, Germany and Ireland, and you want to do the so standard deviation. So the standard error formula, obviously, standard deviation over n. So what we can do is we can use our summary table here, and in the summary table, we can filter out for Germany and Japan. So if you go here on the filter, so we can just select Germany and Ireland, sorry, not Japan. We have Germany and Ireland, right? So we'll get these two countries, right? And if you go to the questions here, so for Germany, we want to get the standard error, so we can use the standard deviation. So if you go here and standard deviation of life expectancy of Germany, so this is the standard deviation, and that divided by square root of the total count of life expectancy for Germany. So here's the total count. Oh, sorry. Um, right? Yeah. And this is not exactly zero, it's rounded. So this is the exact standard deviation. And then similarly for Ireland, we can do the same thing. So we go here, pick the standard deviation, and that divided by square root of the count. So these are the two standard errors for Germany and Ireland, right? And then the pool standard error is just the square root of squares of these standard, sum of squares of these standard errors and their square root. So basically, square root of our this square plus this square. So that's your pool standard error. Okay, so we are interested in seeing whether Ireland's average life expectancy for the last 10 years is greater than Germany's. Write the null and alternative hypothesis you would use to guide this comparison. So, our null hypothesis, so we are interested in seeing whether Ireland's average life expectancy for the last 10 years is greater than Germany's, right? So the average life expectancy for Ireland for the last 10 years is not statistically. Uh, we can, instead of using statistically different, we can use statistically higher, as the professor said, higher. So that would be a null hypothesis, and the average life expectancy of Ireland is your alternative hypothesis would be average life expectancy of Ireland is statistically higher than average life expectancy of Germany. Now, again, this is a one-tailed test because there's only one direction we are interested in. Um, so we want to use this to do our t-test. So if you go here on the sheet 4F2, um, we have the data here, but what you can probably do is I'll add another sheet and show. So let's remove the filter from here. So if you go in this sheet, you can filter out for Germany and Ireland again, um, by country name, sorry. So pick Germany and Ireland from here. Ireland and Germany, right? Um, and you can, so pick the data of Germany from here, life expectancy, right? And then the new sheet that we have here, paste it here, uh, and maybe call this column life expectancy Germany. And then pick the data of Ireland here. And call it life expectancy Ireland, right? So now you have two data, and now you can again do the detailed test. Um, and we are assuming equal variances again. Um, right. Yeah. So do the tool pack and t-test for assuming equal variances. And then so variable one would be the Germany. Variable two would be Ireland. Hypothesized mean difference is 0. And let's print the results here. So now you'll get this. Um, and so the t value is minus negative. So that means that the value of Germany, life expectancy of Germany is lower than uh, life expectancy of Ireland. So that's the first thing we check. And the p value is uh, less than 0.005. So we'll accept the null hypothesis. Sorry, we reject the null hypothesis and we'll accept the alternative hypothesis. And in this case, we can say that the average life expectancy of Germany is lower than Ireland, uh, or Ireland's is greater than Germany's, which is what we wanted to test. So we can accept the alternative hypothesis that the average life expectancy of Ireland is greater than Germany. So does everyone get this? Any confusion, any questions? So I've done 4. Do you want me to do 5, or is it chi-square test, or should I stop here?
Um, yeah, let's take a break. Let's take a break.
Okay.
I'll come back. Let's
Okay.
take a break and come back. Clock is not very accurate. 35. Come back 35.
Do you want me to continue after this?
So, question 5 is
Yeah. So, do you want me to continue right after this, or do you want to do a lecture and then come? So I can.
how many questions would
Issues just. I
Just the one
just-
chi-square.
Yeah, because 6 is linear regression.
So linear question. F 1, 2. So this 1, 2 already.
4 is done.
4 is
So now
already
this
done.
5 is.
5. Let's finish this. Let's finish this.
Okay.
But when do we finish this?
So, yeah. You just, 135, you know, 35 minutes with exit.
Let's do this as a first practice. Well, when I come back, let's do this again.
Okay.
I just see that are a little bit of tired, get a little bit of rest.
Yes.
So yeah, let's finish this and then we all catch up. Right?
Yeah.
There's nothing we left.
Okay. So the last question is chi-square test. So we want to create two new variables, categorical variables. We did this in the earlier practices also. So if you go here, we have this categorical variables. And if you want to um, create, yeah, so to create these, like you can copy paste all this data from the pivot table, and let's say create a new sheet and then paste as values. And you can remove. So we want to do it for the uh, GDP and life expectancy category. So you can remove or hide all these um, necessary variables. So we have two categorical variables, high and low. So for high or low GDP, and then high or low life expectancy, right? And you can use the if formula here. So that's okay, so this one's $3, right? So you can use the if formula. So if and our logical test is that if the average of GDP for that country is greater than the overall average, so is it higher than the overall average here? Grand total, is it higher than the overall average? Then say high. Otherwise, say low. Sorry. And you can drag it. Mhm. Oh, sorry. You have to keep this constant, right? And then similarly, you can do the same thing for life expectancy. So if the value of life expectancy is greater than the total average, keep this as constant, then say high or no, right? And then you can drag it down. So we have So we have these two categorical variables. There's also a sheet here created for those. Yeah, so we have these two categorical variables, and then you want to create this low and high pivot table where you have the one variable as column and one variable as row. Uh, and the way I just quickly show you, so you can select these two columns and say insert pivot table from table range. And then if I want to input it here, um, let's do that. So you can go here and you can select one of this as the rows and then the other as columns, and then use one of this as rows, sorry, values, and it will give you this. So high, low, right? Um, so um, once you have this table of low, so there are 78 countries which have both life expectancy and GDP low, 90 countries which have a high life expectancy but low GDP, and so on and so forth. So then we calculate our expected values, and you know the formula for expected, that you take the total of the row into total of the column divided by the grand total. So in this case, if you're calculating the expected value of this low, we take the row here, the total of that row multiplied by the total of the column in which it is and divided by the grand total. So I'll show you for one of these. So this multiplied by this divided by the grand total, right? So you'll get it for all four, right? The expected values. And so then you can create the test statistics table, and the formula for that um, was that expected minus observed square divided by expected value. So um, expected minus observed square, and that divided by the expected value, right? So you calculate for these for all these four numbers, and if you sum them up, you're going to get your actual chi-square, right? The observed chi-square. So in this case, you sum all of these up, these four values, and you'll get 10.84. So your degrees of freedom is basically the categories of GDP -1 into categories of life expectancy -1. So both have two categories. So 2 minus 1 into 2 minus 1 is 1 degrees of freedom, right? And from that, you can calculate the theoretical chi-square. So you use the formula chi-square distribution. No, wait, sorry. Oh, which one was it? Yeah, chi-square distribution. And it takes three inputs. So first is your x value, which is your actual calculated chi-square, your degrees of freedom, and for cumulative, you want true. So you put in true, and you'll get this. So your theoretical chi-square is lower than your actual chi-square. So what would you do in this case? Anyone? Yeah.
Check.
Yeah. So you reject the null hypothesis and you accept the alternative hypothesis, which means that uh, there's a statistically significant relationship between average GDP and average life expectancy. And the other way you can do it, you can calculate the p-value, and that's the other formula. So chi-square test, and it takes the actual range. So this is your observed range and your expected range, which is this. So it's going to give you a p-value, and in this case, the p-value is lower than 0.05. So there are two ways to do this, right? Uh, any questions? Okay.
Okay. We'll post this online.